Hello everyone, welcome back to our college algebra course. Today I'm going to cover two sections, 3.2 and 3.3 for this week. And I actually covered section 3.2 already when I was talking about section 3.1 I mean. But let me just recall what is in section 3.2 so you see that you actually seen the whole thing when we watched the video clip on 3.1, okay? So basically 3.2 was talking about two things. The graph of a function and the vertical line test. Vertical line test. So you see the somehow I thought it was on 3.1, so I covered the portion of vertical line test on 3.1, so it's a good chance to recall. So vertical line test is a test used to see if a graph is a graph of function or not. Say you have any random graph, right? And you draw vertical lines. If you cannot find any vertical line that intersect the graph at 2 points or more, then it is a function. So this is technically a function. But if you have a graph, say something like this, you see that I can draw a vertical line right here that intersects the graph at 2 points, and I claim that this curve right here is not a graph of a function. Okay, it's a graph of some equation, but not a function. All right, that's about the vertical line test that we covered last time. And graph of function. So technically, you guys know graph already. So let me give you an example. Say f of x equal to, make it easy, 2x plus 3, right? Whenever you guys talk about graph, you think of f of x like y. So instead of writing this way, if you want to see some easier version, you can write this way: y equal to 2x plus 3. And I claim those two things are the same. The first expression is written in terms of function, right? F of x, a function with input x. And then when you graph, what? You got x for x-axis and y for y-axis, or y value and x values. Okay? And how do you find a point on the graph? Say you plug in the value of x when x equal to say 1. You plug in x equal to 1 right here. Let me plug in both. Okay? If I plug in the first one, I got what? F of 1 is equal to 2 times 1 plus 3, which is equal to 5. If I plug in the second one right here, I got y is equal to 2 times 1 plus 3, still equal to 5. So either way telling you what? Y is equal to 5. So the point 1, 5 is on the graph. So you know that you can plug the point 1, 5, it's going to be on the graph. Okay? Or maybe the other way around. They give you a y value. They want you to calculate x. So say I give you y is equal to say 5. Or 5 already. So about 7. Okay? Y equals 7. Or f of x equals 7. By the way, it's the same thing. Or f of x equal to 7, because in here y and f of x actually the same thing. So how do you solve for x from here? Well, you plug in y equal to 7. You got 7 is equal to 2x plus 3. Subtract the 3 on both sides. They got 4 equal to 2x. So x is equal to 2. So the point on the graph will be 2, 7. Okay? Pay attention. What x always go first, and then comma and then y value. Right? So when y equal to 7, you can solve for x. And you got x equal to 2. So the point 27 is also on the graph. So this is really everything about 3.2. That's why I usually combine 3.1 and 3.2 together. Not big problem here. Say you have a function or you have an equation right here. You want to find a point on the graph. You give an x value, you can calculate y. Or the other way around, if people can give you y value, you can calculate x. Okay, you have the point on the graph. And then when you have a lot of points on the graph, you connect them together, you have the graph, a roughly sketch of the graph. Okay? And of course, we talked about the vertical line test already. So that is a brief review of what we have on 3.2. And let me move on to the really main big section for the day, section 3.3. All right, let's get to business. 3.3. We'll be talking about some basic properties of functions. Okay? So let me this way, properties of function. Of course, function functions have a lot of properties, okay, a lot of important properties. So in our course, college algebra, I'm going to show you some fundamental, basic, very fundamental, very basic properties of function that will carry with you when you study college algebra, pre-calc, calculus. All those properties are going to be very helpful when you learn. Okay, so let's start with the first property. We're talking about something called even and odd function. Okay, so let's start with first number one, even function. Okay, so for now, it means at our level, college algebra, whenever you guys hear the word even function, what should we think of? Whenever you guys hear the word even function, you should think of the graphs. This graph of this function is going to be symmetrical. Excuse me. It's going to be symmetrical about the y-axis. Symmetrical about the y-axis. Okay. Actually, we learned about symmetry about the y-axis before. I think, what's that? Last time we talked about property of equation in general in I think chapter 2. Whenever you want to test to see if an equation in general, now we talk about function, which is a part of the equation. Okay? We want to test to see if it's symmetrical about the y-axis. Say the y-axis is right here. Symmetrical about the y-axis, right? Means what? The point on the right-hand side of the y-axis, when we flip over the y-axis, we still have another point on the graph. So what? This point is x comma y. Flip over is going to be negative x comma y. And we learned what? We want to test for symmetry about the y-axis. We replace x by negative x, plug into the equation. And that's exactly what we're doing in here. But we don't test in general for equation anymore. We just talk about function. So we say what? If the function that's symmetrical by the y-axis, we say the function is even, or it's an even function. Example, y is equal to x squared plus 1. All right? That is how we write before. And now in terms of function, instead of writing y, you can write it this way. F of x equal to x squared plus 1, which means exactly the same thing. All right? So if you have a function, you don't like working with the function notation, you can rewrite it as y equals to x squared plus 1 and come back to what we learned in chapter 2. Okay? You have a function or an equation. Same thing. Now, you want to test for symmetry about the y-axis. Now, we say what? We want to test to see if the function is even or not. Okay? Two different ways of saying the same thing. Okay? So, how do we know is this symmetrical about the y-axis or not? Or another way, how do we know if the function is even or not? We do what? Replace x by negative x, right? Replace x by negative x, right? That's what we learned before. So if I write this way, then what? The original one is y equal to x squared plus 1. The new one is y equal to negative x squared plus 1. Simplify. We got y equal to x squared plus 1. Those two are the same. And then you say what? The equation or the graph is symmetrical about the y-axis. That's exactly what we learned before. Now, in terms of function, you technically do the same thing. So replace x by negative x, right? So this is f of x equal to x squared plus 1. When you replace x by negative x, you got what? F of negative x is equal to negative x squared plus 1. And simplify, of course, you got what? Still f of negative x equal to x squared plus 1. Okay? So we are doing the same thing. We're just talking in the language of function instead of equation in general. Alright? So when I replace x and negative x, I got the same function. Or you say the same equation. Same. Okay? And you can say what? The graph is symmetrical about the y-axis. When in terms of function, we say what? The function is even. So you say what? Even function. Okay? So, the idea, the concept of even function is equivalent to the idea of what? The graph is symmetrical, being symmetrical about the y-axis, exactly the same. Okay? So, you want to test for even function, whatever you do with symmetry about the y-axis, you do the same for even function. Which is, this one right here. Replace x by negative x and plug into the function. If you got the same thing come out, you're going to have an even function, or the graph is symmetrical about the y-axis. Okay? So, for even function, this is what you needed to check. You see what? The test, you see. Let me write formula. A function f of x is even if f of x is equal to f of negative x. Let me box that. Alright? So, what do we mean right here? If you replace x by negative x, the function doesn't change. Then you have an even function. And graphically, see you have one point right here, x, f of x is y, right? You replace x by negative x. It's on this side, right? And it's still on the function. The graph goes like this. That is even function. This is negative x comma y. Okay. Now let's move on. We're going to talk about another type of function, another property of function. We have even function, right? So the second type, as you can guess, we'll be talking about the odd function. Number 2, odd function. Okay, and graphically, odd function will be symmetrical about the origin. About the origin. You may ask, why don't we talk about symmetry about the x-axis? Because I learned in terms of function, usually, okay? Most of the time, I would say, whenever something symmetrical about the x-axis is not a function. For example, say you have a graph right here. Right? It's symmetrical about the x-axis. This is my x-axis. You see what happened to this curve? It will fail the vertical line test, so it's not going to be the function. Unless the function is the x-axis itself, and that'd be okay. But that was the only case. Okay. You see that this is not functional at all. That's why we will not be talking about symmetry about the x-axis. Only symmetry about the y-axis and the origin. And again, one more time, symmetry about the y-axis, you got even function. Now we'll talk about symmetry about the origin. You're going to have odd function. Okay. So recall, what do we do to test for symmetry about the origin? Right? Let's draw the graph. Hopefully that's helpful. Okay? A function is symmetrical about the origin. Means what? You have a point on the graph, x comma y. You flip over the origin, you still have another point on the graph. So this is x comma y. Flip over the origin, you have what? Negative x and negative y. And that gives us a hint how to find, how to test for symmetry about the origin. What do? You change x to negative x, and you change y to negative y. And of course, the same thing for odd function. Okay, so let me give you an example. Example. Say y equal to x cubed minus 4x. Oh, I say 4x, okay? Alright, so in terms of function, instead of writing y, you write it what? F of x equal to x cubed minus 4x. Those two things are exactly the same. Function, okay? So it's an equation. All right, and how to test for symmetry about the origin? You change both x to negative x and y to negative y. Yeah, change x to negative x and y to negative y. Okay, so let me recall what we did before. If we write it this way, y equal to, all right, in chapter 2, I think. So y equal to x cubed minus 4x. We change y to negative y. We change x to negative x cubed minus 4 times negative x. And simplify, negative y is equal to negative x cubed plus 4x. Now you multiply or divide both sides by negative 1. You got y is equal to x cubed minus 4x. See what? The original equation and the new equation are the same. And you say what? The graph will be symmetrical about the origin. Okay? In terms of function, I claim that you guys do exactly the same, right? You change y to negative y and you change x to negative x. See if it's the same. So what do you mean by y to negative y and x to negative x? Say x to negative x, you got what? F of negative x, is that right? Is what? Negative x squared minus 4 times negative x. Okay? And now simplify a cube, I mean. Okay? Is what? Negative x cubed minus, with the minus become plus 4x. Okay? And this is f of negative x. Which is y right now. How do you change to negative y? You gotta put another negative in terms of f of negative x, and this is f of negative x. Okay? I change this x to negative x. Now I gotta change y to negative y. How do I change y to negative y? Y is f of x, so negative y means what? Negative of f of x, negative of f of negative x. Be careful. The idea is the same, but you may have some confusion when I put a lot of negative in here. This negative right here goes with x. Change x to negative x. I got this. Okay? Now, I gotta change y to negative y. So it's a function. I change f to negative f. So negative of the whole thing. Now watch me carefully. Negative of the entire function is this. Negative of negative x cubed plus 4x. You see? You see what I've done? I put the negative in front of the entire function. And that means I put a negative in front of the whole thing. And of course, we can simplify this. You got what? X cubed minus 4x again. Okay? And you see what happened? The original function and the new function going to give you the same thing. Okay? And that'll tell you what? The function is odd. So we don't just change x to negative f. We also have to change f to negative f. It's another way of saying y to negative y. And be careful right here. In here I can replace both of them at the same time. But in here the notation may be confusing, so I do one step at a time. Replace x by negative x. First, simplify, make it easier. Then replace f by negative f. Put it in. You can do both at the same time, but be careful because it may be confusing. So I'll just do in a simple way. Okay. And again, if you don't like working with the function notation, just always write back to y equal to x cubed minus 4x, and then replace x by negative x, y by negative y. You test it the same way. You say what the function is odd. Okay? If you have the same equation coming out, the same function coming out. So let me just write it. A function f of x is odd if f of x equal to negative f of negative x. Right? What we're saying in here, we replace x by negative x, replace f by negative f. You have the same function, and then you say that the function is going to be odd. Because the because of the odd function may be a little bit more complicated than the even function when you actually deal with mathematics. I think I better give you another example. Hopefully it's going to be helpful. Give you an example, another one example. Given the function f of x, now I'm talking about function, okay? F of x equal to, make another one. Let's think of something. How about 1 over x? Okay? And I want to test to see if this function is odd or not. So how do I test? I have to calculate what negative f of negative x, right? We show you step by step. What is f of negative x? Is equal to 1 over negative x. Alright? Now, negative f of negative x, you see? We have double negative. Negative of f and then negative of x right here. Negative of make it that way if it's clearer for you, but usually people don't use square bracket, and I just want to emphasize it. I put negative in front of the entire function, which is negative of what? 1 over negative x in here. See, this is f of negative x. F of negative x right here, then negative of it. Then double negative, make it positive, so 1 over x. You see what? The original function and the new functions are the same. Right? In other words, f of x is equal to negative f of negative x. F of x equal to negative f of negative x. And what do you say? The function is odd. Okay? So for testing for even function, you need to do one step, replace x by negative x. Okay? For odd function, you have to do both. Replace x by negative x first, then put a minus sign in front of the entire function and simplify. Okay, that was everything about even and odd function for now. Let me move on to the second item on 3.3. I'll be talking about another property of functions, increasing, decreasing function. So let me put it in a formal way, a fancy word for it. Monotonicity. Monotonicity. Actually, this is a very fancy word we use in mathematics. It means what? Increasing or decreasing. Increasing or decreasing function. Okay. So graphically, what do we mean by increasing function? Increasing, going up. Decreasing, going down. Okay? So this is increasing. This is decreasing. Okay? And algebraically, what do we mean by increasing? Means what? Whenever you plug in a bigger value of x, a bigger input, you get a bigger output y. Okay? Bigger x, bigger y. Increasing. It decreases the opposite of that. You have a bigger x, you got a smaller y, decreasing. Okay. And this property is a local property. It may not apply to an entire function, but it's going to apply on interval. Okay. So 1 increasing. Okay. What? If x1 is greater than x2, then f of x1 is bigger than f of x2. What we're saying is what? You have a bigger x, you get a bigger y. Bigger input, you get bigger output. Okay. This way. Larger input give larger output. Okay. Example. How about this? Let me finish the second one. You guys compare, and then I'll give you example at once. Okay. Talk about number 2, decreasing. Decreasing is the opposite of increasing, right? If bigger x is going to give you smaller y. So if x1 is greater than x2, x1 is the first input and x2 is the second input, right? The first x is bigger than the second x, then f of x1 now will be less than f of x2. Then we say the function is decreasing. Okay. So in here, what? Same direction, right? X bigger, f of x bigger is what? X bigger, then f of x is smaller. Okay. And then the way you say is what? Larger input give smaller output. Okay? It's whenever I write in quotation marks, this means this is how we really interpret it. Okay? Interpret it. If I write without the quotation mark, this is like a formal definition of it. Okay. Now I think it's good to give you guys an example. And for now, we're going to determine whether the function is increasing or decreasing by looking at the graph. Okay, so we do it graphically, but I keep emphasizing it. Looking at the graph, observation is not an appropriate way, not a formal way to do mathematics. You guys will learn in a formal way when you get to calculus 1. We have to do algebra. We got to do derivative to find the interval increasing and decreasing. But this is like beyond our scope, the course. So we just by observation, we look at the graph to tell. All right. So let me give you an example. F of x is equal to make it easy, right? X squared minus 1. So let me sketch a graph of this one for you. This is actually a parabola, -1 right here. This is the x-axis, and this is the y-axis.